Given a bunch of points and circles on a 2D plane, how do you efficiently count all the points fall inside each circle without using any floating point math at all? So let's break it down. So hello guys, welcome back to the channel. I am Rachit Kakkad. In the channel, we solve competitive programming questions and also along with it we crush the DSA. Our motto is one problem at a time. If you are new to here, smash that subscribe button and drop a like. It genuinely helps the channel to grow. So today we are solving LeetCode question 1828, queries on a number of points inside a circle. So let's get into it. You are given an array of points where a point is an x, y ordinate on a 2D plane. You are also given an array of queries where each query is a circle defined by its center x, center y, and radius r. For each query, count how many numbers, how many points lie inside or on the border of the circle. So we have to count both and return an array of answers, one per query. Example 1, we have points are 1, comma 3, 3, comma 3, 5, comma 3, 2, comma 2. Query 1 is a circle centered at 2, comma 3 with radius 1. Three circles fall inside it. Query 2 is centered at 4, comma 3 with radius 1. 2 points. Query 3 is centered at 1, comma 1 with radius 2. 2 points. Uh, Output is 3, 2, 2. Points on the border count as inside also. So that's a key detail. Uh, then, how do we check if the point is inside or outside of a circle? The distance from the point of to the center must be less than or equal to the radius. That's the formula for it. Then we have to use the distance formula, which is square root of dx square plus dy square, where dx and dy are the difference in x and y coordinates. But we never actually need the square root, right? Instead of checking if the distance is less than or equal to r, we check if dx square plus dy square is less than or equal to r square. We can check that also, right? Not need of square root, sorry. Same condition, no floating point, no square root, just pure integer match, which we have done in 11, 12 maths also. So basically we are using that here also. For each query, we look through all the points, apply this check, count all the ones that pass, simply nested loop approach. That's how it is. Let's walk through the code. We were doing the code in C++ as we are pressing down the DSA. जो है हमने DSA का. So let's start with it. RT is our result vector, one entry per query. That's what I thought for it. Uh, for each query, we extract the circle center Cx, Cy, and radius r. We pre-compute the r square and r2 right here, so we don't have to recompute it at every single checkpoint inside the inner loop. And Ct is our count query, count for this query, which starts at 0. If you don't know about the auto keyword and address of p, please have a comment. I would make a dedicated video for it also. Here I forgot to add the, subtract the cx and cy. For every point we compute dx and dy, the difference in x and y from the circle center. Then we check if dx square plus dy square is less than or equal to r square. If yes, then the point is inside or on the border. Then increment ct. No square root ended anywhere. So that's what the basic thing was. After checking all the points for this query, push it into the result, repeat for every query, return at the last, return the RT. Let's try run on query 1. Center is 2, comma 3, radius is 1, R square is 1, point 1, comma 3, dx is negative 1, and dy is 0. 1 plus 0 is 1. 1 is less than or equal to 1 inside. Point 3 comma 3 dx is 1, dy is 0. 1 plus 0 1 inside. Point 5 comma 3 dx is 3, dy is 0. Then 9 plus 0 is 9. 9 is greater than 1 outside. So this point would be our outside point. Next point we have was 2 comma 2. And then dx is 0, dy is negative 1. Then 1 plus 0 plus 1 is equals to 1. That's inside. Count 3. That's our answer. Correct. Let me hit the submit button so you can know that is this a correct solution or not. Once a second. Sorry guys for the error. I guess there is no dot. There is an underscore pushback for it. Let me hit the submit button again so we can have the correct one. Yes, here you can see that the solution got accepted, and the time complexity for this is the order of n times q, where n is the number of points and q is the number of queries. Since both are at most 500, that's 250,000 operation completely fine. Space complexity is order of q for the result array. The problem asks, can you do better than this order of n per query? For this, constraint size is constraint size doesn't matter. But for the large input, you could use a 2D prefix sum approach. It would like pre-compute how many points exist in every subrectangle, then answer each circle query by approximating with the boundary boxes. That's bring query time way down than we are having currently. Worth mentioning in an interview to show you are thinking ahead. Uh, so that's it. That's a LeetCode question 1828. Where is the number of points inside the circle? The key insight is never compute a square root. Compare the square distance inside. Pure integer, no maths, no precision, clean and fast. If this helped, drop a like. It seriously matters a lot. And subscribe so you never miss a video. Till then, bye.